Rusty, you're the astronaut on Apollo 9 who would be considered the rookie. You haven't been into space before, so let's tell our listeners something about you. Where were you born?
Well, I was born in Neptune, New Jersey in 1935. It's a little town about 60 miles south of New York City on the coast there.
At the time that you were a little boy, did you get interested in this thing called outer space, as most little boys did?
I think all little boys do. The first love, of course, was watching all the airplanes fly overhead, and that was during the war years and when I first became aware of airplanes, and I used to be up there dogfighting above the house, and that was lots of fun to watch them. And I was born out in the country, so I got to see a lot of the moon up there in the night sky, and that fascinated me too. And I can remember from when I was a little kid, two things I always wanted to be was a cowboy and a pilot. So.
Well, when did you start toward the career as a pilot?
Well, when I went to MIT,
Massachusetts Institute of Technology.
Right. I joined the Air Force ROTC there with the intent of going into flying. And in my sophomore year at MIT, I also elected to study aeronautical engineering. So those two married pretty nicely. And after I left MIT, I went through Air Force pilot training as an officer from the ROTC, and spent several years in the Air Force flying fighter planes, both overseas and in the States.
When did you go back to MIT for your master's, or did you do that at the same time?
No, I finished MIT in 1956 with a bachelor's degree in aeronautical engineering, and then went into the Air Force, and after training went over to the Philippine Islands, spent 4 years in the Air Force that time, got out and went back to MIT for advanced studies. And of course that was when the Berlin Wall went up and I was recalled to active duty. I was flying at that time with the Air National Guard in Massachusetts, and went back over to Europe and spent about a year in France and Germany in 1960 and 61. And after that year was up, we came back to the States, and I finished up my master's degree in aeronautics and astronautics at MIT.
Mm-hmm. And you've become interested in astronomy throughout this career too, haven't you?
Right. I've always been interested in astronomy from the time I was a kid, and during my years in the Air Force I had the opportunity to grind my own telescope lens, or mirror I should say, rather than lens. And after making a 6-inch telescope, you become very interested in astronomy. When I went back to MIT for my advanced work, I worked in a laboratory called the Experimental Astronomy Lab, and we did a good bit of work on upper atmospheric physics and stabilization of optical images, in particular stellar images.
In fact, your master's thesis had something to do with stratospheric phenomena, didn't it?
Yes, I had an experimental thesis, which is always a little bit dangerous, because if the gear doesn't work right, you don't get to write your thesis. And we had several mishaps, but we launched payloads under balloons, which went up to about 100,000 feet and studied the radiance of the upper atmosphere.
Mm-hmm. Do you think it's the scientific background added to your pilot experience that enabled you to be selected in the astronaut program?
As a matter of fact, at the time that I was selected, I think that's very true. I came in the third group of astronauts selected in the fall of 1963, and at that time there was more emphasis being placed on scientific training and a slight de-emphasis on the test pilot aspect. And you had to have at least 1,000 hours of jet time to be selected, which I had, but I was not a test pilot. So my training at MIT and my research work, along with my fighter pilot experience and jet time in the Air Force, enabled me to get in at that time. Now you have to have at least a doctorate in the physical sciences to get in, and I probably wouldn't hack it.
But now you're flying on Apollo 9 as the lunar module pilot, and you're prepared for this EVA, this extravehicular activity.
Right. I hope I'm prepared. We've spent a lot of time in getting ready for it, and it's a lot of hard work, but I hope it's going to pay off here.
Rusty Schweickart, on the third day of the Apollo 9 mission, you're scheduled to, for the first time, go into the lunar module and turn it on. Let's talk about that. What do you do, first of all?
Well, in the beginning of the day, after Dave Scott and Jim McDivitt have removed the probe and the drogue and cleared the tunnel, then I progress through the tunnel into the lunar module, which has been powered down all of this time, since there's been no one in it for launch. The only thing that's been on electrically in the lunar module are a few heaters which are required to keep some gyroscopes and that sort of thing warm. But aside from that very small power in the LEM, no one knows its status. The ground doesn't know its status at this time, nor do we. Supposedly everything is okay because nothing's been going on, but it's the first spacecraft that we've flown with that we get into at this time and power up actually in orbit. So as soon as I get into the LEM, I make a check to see that everything is proper, that has survived the launch, that we don't have circuit breakers that have popped open and that kind of thing.
Are you the first man in?
Yes, I am the first one in that day.
And you're in a fully pressurized suit going through that tunnel too, aren't you?
Well, we have the full pressure suit on. However, it's not pressurized because we do have a normal environment. We have 5 pounds per square inch of pressure in both spacecraft and the tunnel, so that the only reason we have the pressure suit on is in the event that something happens on the way through to the pressure vessel. Then, of course, the suit protects us. But it is what we call a soft suit operation.
About how long will it take to power up the lunar module?
Well, from the time I start in until we're powered up and ready to actually go into operations, full-scale operations like lighting the descent engine, for example, which we do this day, it takes about 7 hours. But now that 7 hours, it must be remembered, is spent in checking systems the way they would not normally be checked. Because this is the first flight of the lunar module, we're interested in not only running all of the various systems under their normal operating conditions, but also to employ the backup techniques that are used on these systems, the redundant components. Instead of just checking one suit fan, we check both of them. We check the automatic transfer from one glycol pump to another, and this kind of thing. So we actually go through more than what would normally be done, since this is the first flight of the lunar module. Now, after we get all of this powered up, then we go into our first what you could call operational mode or operational test in the LEM, and that is to light off the descent engine. That's the throttleable rocket engine on the bottom of the descent stage. It's got about 10,000 pounds of thrust and a capability to vary that down to 1,000 pounds manually. So we go through a long propulsion, what we call burn of that engine. The burn will last about 6 minutes. And we'll go all the way from 100% thrust on the engine down to 10%, throttling it manually and that kind of thing. And that's a simulation, so to speak, of the lunar descent, the burn that we'll have on that engine on the lunar mission.
This is almost a little discussion in itself, is this first descent propulsion system burn with the 2 docked vehicles. Now, this is going to be quite crucial in your check-out of the combined vehicles there in this first manned flight with the lunar module. Will the other 2 pilots be looking very carefully at the way that this mass of the Apollo command module and LEM are holding together during this burn of the big rocket?
Yes, that is one of the considerations. Let me point out one thing that I may have misled people on here. As soon as I get the LEM initially powered up, then Jim McDivitt comes over and the 2 of us operate as a crew in the lunar module, the normal 2-man crew, going into this what we call a docked DPS burn, which is a docked descent propulsion system burn. The primary purpose of this burn is twofold. Primary purposes, I should say. The first is to verify a long duration firing of that engine, which would of course be used on the lunar descent, as I mentioned. The second purpose of this burn is to look at the guidance system, the capability of the guidance system to control that great big long vehicle now. You see, we have the 2 docked together, and it's almost like 2 weights connected by a noodle, so to speak. The docking tunnel is quite small in comparison with the mass of the 2 vehicles, so that the guidance system has to be very gentle or subtle in the way it controls the docked vehicles. And we're evaluating the capability of getting out of lunar orbit in case something went wrong with the service module engine, we can now, since we're still docked, use the lunar module descent engine to get us safely back to Earth on the proper trajectory. And the second purpose of this docked EPS burn is to evaluate that capability.
Rusty Schweickart, you have some experience to draw on from astronauts who've been there before you on extravehicular activity, or a walk in space, as many people on Earth call it. How do you feel the experience is going to be for you?
Well, I think it's going to be a very exhilarating experience. I can't think of a more beautiful sight than those two vehicles docked together up there over that beautiful Earth. And I'm looking forward very much to getting outside on this EVA and seeing that sight, as well as getting the job done, which is, of course, why we're there.
You want to briefly run through how you'll come out of the LEM and go to the command module and back for us?
Yes, perhaps I should say a word about the equipment that we're using so that people can appreciate the situation. I have on my back what we call a portable life support system. And this portable life support system includes oxygen for breathing and oxygen also for pressurizing the suit. We run with about 3.8 pounds per square inch of pressure in the suit. This oxygen is circulated through the suit to remove carbon dioxide, which is removed in the backpack by a lithium hydroxide canister. As well, I have what we call a liquid-cooled garment on, and this is essentially a pair of long underwear with a lot of tubes in it, which through which circulate cool water. And this water is then in turn cooled within the backpack by sublimating water. We have what we call a sublimator, and this, of course, evaporates or sublimates water to space, thereby rejecting the heat from my body.
And if people see pictures of you in your EVA suit with this big box on your back, then this is what you're describing right now.
That's right. And in addition, of course, to these life support things, it also has a set of radios in it which allow me to communicate both with the other two spacecraft and also with the ground. And of course, communications is very important, especially on the lunar mission. And of course, this is the gear that we will use, the equipment that we will use on the lunar surface for the lunar explorations. Now, this is the first check of this gear, and of course is one of the primary purposes of the EVA on our flight. Mounted directly on top of the PLIS, or Portable Life Support System, is what we call an OPS, or Oxygen Purge System. This is, I think you'll be able to see on the pictures that we come back with. This is a separate little box on top of the big box on my back, and this is an emergency oxygen supply system. In case something goes wrong with the normal portable life support system, I can use this emergency system for about a half an hour, which gives me adequate time to get back into the spacecraft and get everything pressurized. Now, the second purpose of the EVA on our flight is to demonstrate the capability to go from the lunar module back up into the command module externally. That is, in case we have problem with the docking in lunar orbit.
In case you can't go back through the tunnel.
That's right. In case there's something wrong with the tunnel transfer, which is the normal way to go, then we would have to go external. That is, we would have to depressurize both spacecraft, open the hatches on both spacecraft, and transfer externally across a set of handrails from one vehicle to the other. This would allow Jim McDivitt and I, or in the case of a lunar mission, the two pilots of the LEM, to get back into the command module so that they can then commence the return to Earth. And so on our flight, we're demonstrating this capability to transfer from one vehicle to the other externally.
How much have you trained? How much have you trained for this sort of exercise in weightless environment?
Well, we have two ways of simulating a weightless environment. One is in an aircraft, a big transport aircraft, which we cause to execute what we call a parabola, which leaves us weightless for about 30 seconds during those flights. And the second is what we call our water immersion facility. It's a great big swimming pool, essentially, in which we weight the suits. That is, we get into the swimming pool, go underwater, and we hang weights on the suit so that we are neutrally buoyant underwater.
Mm-hmm.
And this allows us essentially unlimited time. It's not quite, but we have about an hour and a half that we can exercise underwater here in what gives the appearance of being a weightless situation to train for this. Now, on our mission, we found that the 30-second parabolas that we fly in the aircraft make it difficult to carry on a continuous exercise. You have to do everything in these small 30-second increments, and that makes it a very difficult exercise. Therefore, we have relied heavily on the water immersion facility and the training underwater for zero gravity, and I would say that I've spent 25 to 30 hours underwater training for this EVA.